engineers, Lachlan here. Welcome back to the channel. Today, we're going to be discussing the theorem of superposition, one of the most powerful tools that any electrical engineer can have in the calculation of voltage and current in complex circuits, so make sure you're paying attention. First up, a bit of background. What we're looking at today is only an application of the principle of superposition, a fundamental principle of wave physics. It applies to linear systems only, and states that if input A produces reaction X and input B produces reaction Y, then applying input A and B together, A plus B, will produce the sum of X and Y, X plus Y. Take for example these waves coming together here. As A and B approach and then intersect, they will superimpose, constructively interfering to create a larger wave, A plus B. Much like these waves, we will be investigating our circuits to determine the separate inputs and their reactions, then superimposing them to determine our final reaction. We're going to do that through an example, so let's begin. What is the voltage across R2? Initially, this isn't the most complex circuit, and admittedly you could probably do this quite easily using some applications of Kirchhoff's voltage and current law and Ohm's law. However, this is a beginning example. So, moving into the superposition theorem, we're going to use step 1, which is to remove our power sources. Replace your voltage source with a short circuit, and replace your current source with an open circuit. Then, as you may be thinking, step 2 is going to be add one source back in. In this example, we're going to add in back our 6 amp current source. Then we're going to calculate R total. Then we're going to use Kirchhoff's voltage law to discover what the voltage across R2 is. So then we're going to note that down and move into step 3. We're going to remove that current source and add in our next source. So, looking here, I want you to note that the open circuit around R3 negates any effect it has on the total resistance. Then, using some simple calculations, we're just going to discover that VR2 is equal to 3.29 volts. So, I also want you to note here that the current flow from the voltage source and the current source are actually opposing. So, we're going to have to take note of that in our final summation of our values. Here we are in step 4, where we're going to superimpose and sum all of our found voltages. So we end up with VR2 is equal to 24.7 minus 3.29, remember the current flows are opposing, and we're going to end up with a final voltage of 21.41 volts. And that's actually all it is. That's the final step of the superposition theorem. So a quick recap. Step 1, remove all of your power sources. Step 2, add back in and calculate the desired voltage. Step 3 is to repeat step 2 until all power sources are accounted for. And then step 4 is simply to sum the results to find your final voltage, making sure that the current flows are not opposing. Alright, so thanks so much for watching everybody. I hope you've learned something today, and I hope you'll keep this tool in mind when you're calculating the current and voltage in circuits. Thanks for watching.